Alright guys, so today we're going to focus on creating systems of linear equations and actually coming up with the systems. I'm always going to give them to you guys, so again, feel free to pause, rewind. You guys know the drill. So before we get into it, here are some helpful tips when creating equations. So number one is you want to make sure that you are organized. Alright, biggest issue is if we're all over the place with these kind of word problems, again, make sure you're organized. What I always like to do to help me out with this is you want to make sure that you go through and you highlight stuff. Okay, the important stuff, not just everything, right? Highlight / underline if you don't have a highlighter. And again, you're looking for those key numbers, key words. The second thing that always helped me out was to draw a picture. Okay, it sometimes just gets overwhelming, and I understand. So again, draw a picture. You can actually see it a little bit better. The third tip that I have here is look for those keywords. So look for key words specifically for us is those change in rates. Okay, so what I mean by that is what things are changing. Remember we talked about that word per. So if you have like per month, per taco, per whatever, or if you even just have the word alone, monthly. So things like that you want to look for. Those are the things that are changing. So if I say, hey, $20 per month, you know you're going to have something that looks like 20x. Or if I say there's a weekly fee of $15, so weekly fee of $15, well, $15 per every week. I can even use the letter W here to represent weekly. I could have said M for monthly up here. The last one is you're going to be solving systems. So select best method here. So again, you can solve by graphing, substitution, elimination. All right, and I'll show you guys which one I use and why I use it. All right, so let's look into the very first one. It says Mallory is putting money into savings account A, starting with $150, and account B started with $300. Mallory deposits 16 in account A and 12 in account B each month. In how many months will account A have a balance at least as great as account B? So when will they be the same? And then here's the other question, what will that balance be? So let's go through. What I want to do is I want to underline. So here I have two situations. I want to make sure that I tell them apart. So I have account A that started with $150. All right, so that's not changing. But then after that, they kind of switch it on us here. This says account B. So here I have account B started with $300. So now I have a different situation. I want to make sure I keep it organized, keep them apart. So let's go back here, and it says Mallory deposits $16 in account A, and then $12 in account B. So I want to make sure that I keep this organized, and I'm highlighting here, underlining, excuse me, in a different color. And here is the key part to this, and it's actually for both. It says the $12 and the $60 are a monthly thing, so it's actually for both of this. I'm gonna underline both in green and in red because she's depositing $16 into account A per month and $12 into account B per month. Okay, and again, we always want to make sure that, hey, do I know what the heck the question's asking? It's saying, when will the accounts balance be as great? So in other words, when will it be the same? And how many months will the account balance be the same? How many months? And what will that balance be? So what is that balance? All right, so here I actually have a system. So let's actually go ahead and, we have to write the system before I can begin solving it. So let's take a look just at account A. It says they started with $150, and then don't forget that it's $16 per month into that account. So if I started with $150, but I'm depositing money in here, so I'm putting an additional $16, but I don't just do that once, I do that actually monthly. So I have to say 16x. Okay, well this should actually equal, well, my total amount, how much my balance. So I'm going to use the variable y here. So that is my very first equation. My balance is equal to the original $150 that I had plus the $16 per month. So again, this is the 16x. All right, so that takes care of account A. All right, but what the heck? What about account B? Well, for account B, they start at $300. So I'm going to start off with $300 here. Okay, but in addition, they're also depositing $12 into account B each month. So it's not just $12 one time, it's also $12 every single month. Now again, of course, the $300 plus the the $12 that I put in every month, my balance should be increasing to give me my total balance after a certain amount of months. Okay, so here, I have my system. Okay, what I want to make sure though before I move on and actually start solving this is, hey, let's recall what is X is representing. So X here is representing $16 and $12, but $16 per month and $12 per month. So don't forget that X represents the number of months. And what the heck do the Y's represents? Well, if I had $150 plus the $16 per month, that's giving me my balance. That is my total. So you can think of this as total. You can say total balance or just simply balance, whatever you prefer. Keep that in mind. That's going to become very, very important. All right, so let's move on here to actually start solving this. I'm going to move on to the next slide. All right, so my system, make sure I get the colors right here. Y was equal to $150 plus the $16 per month. That was account A, and then I had account B, which is Y equals, these guys were $300 plus the $12 per month. Now again, I want to make sure that I make an important note. X was representing months, and Y was representing the balance at the end, or the total. All right, so let's actually solve this now. Again, what approach do I want to take? Do I want to solve by graphing? I could, but do I really? Notice this looks like Y equals, my MX is at the end, my B is at the beginning. I could graph this, but I don't want to go up to 300. I mean, I don't have graph paper, not unless we're using Desmos. So actually, I want to solve this by substitution. I already know what Y is, so my method of choice is substitution. Okay, if I know what Y is here, Y is equal to all of this stuff here. Well, let's substitute. Let's actually plug it into the Y. So I'm going to end up with 150 plus 16x is equal to the 300 plus the 12x. Again, I want to know when these two bank accounts are going to equal each other. So it's kind of nice. I'm actually sending both of them equal to each other. Now it's just a matter of, can we solve this? Can we go through and solve this? If I take here and I subtract 150 from both sides, minus 150, these guys cancel out. I get 16x is equal to 300 minus 150. That is 150 plus 12x. Well, now I need to get rid of that 12x. How do I get rid of a positive 12x? I say minus 12x minus 12x. 16x minus 12x is 4x is equal to 150. The last thing I have to do here is I have to go ahead and divide both sides by 4. All right, now the thing is, I don't know this off the top of my head, so it's okay. I'm going to use my handy-dandy calculator here. So 150 divided by 4 is going to give me 37.5. Whoa, I got a decimal. But hey, let's not panic. All right, let's not panic. This is still doable. All right, so I'm going to take this here, and I'm going to substitute. So I found out what X is. I need to find out what Y is. I'm going to substitute. Doesn't matter which one. I'm going to pick, let's pick the second one. Why not? Y equals 300 plus 12x, but of course Y equals 300 plus 12, not times x, but times 37.5. Now when I multiply 12 times 37.5, I'm going to get, now again, it's okay, we can use a calculator here, I'm going to get $450. Now of course when I add these last two, I should get 750. Now I figured out what X is, what Y is, but hey, give me a sentence here. What does it actually mean? I do have a word problem. So what this is saying, X represents months. So in 37.5 months, both accounts will have a balance. Remember, Y is balance of $750. All right, that's what we're looking for right there. Actually answered both parts of my question. It's not enough anymore just to say X and Y. When you have a real world situation, you got to give me that sentence. All right, here we have the next one. It says the length of a rectangular room is 5 feet more than the width. Hey, they actually give it to us. The length is 5 more than the width. Okay. The perimeter of the room is 66 feet. So that's the perimeter. Let L represent the length of the room and W represent the width in feet and the system equation. So they actually give us a system. We just have to solve it. What are the dimensions? Here's the actual question that I need to answer. What are the dimensions? What's the length and what is the width? Now, if you're curious as to how they got 2L and 2W, well, you have 2 lengths and 2 widths that make up that rectangle. And of course, if you add those together, you get your perimeter. But let's actually get into solving this. And again, do I want to solve by graphing? I have to change the L's and W's to X's and Y's, and I probably don't want to go up to 66. That looks like a very large number. But I do notice that my first equation, I have L isolated all by itself. So substitution, why not? I know what L is. L is equal to all of this information here. It's going to be the easiest one to do here, the most effective way to solve this. So let me plug all of this in for the L. I'm going to get 66 is equal to 2, and then parentheses here. Let me see if I can do this in a different color. W plus 5 is coming from the first equation. And then don't forget the rest, plus 2W. Now, hey, let's go through this. Let's solve a multi-step equation. Easy peasy. Let's distribute real quick. What is 2 times W? 2W, 2 times 5, that is going to be 10, plus 2W. Let me bring down my 66. Hey, what can I do next? Always check. Can I combine like terms? Of course. 2W give me 4W. So I have 66 is equal to 4W plus 10. Now, how do I get rid of that 10? Let's say minus 10. Minus 10. Well, 66 minus 10 is 56 is equal to 4W. Last thing I have to do here is divide both sides by 4. 56 divided by 4 is going to give me 14. 14 is equal to W. Now, again, what does W represent? Well, width. Now again, it's the width in feet. So I'll give that sentence in a second. How do I get the length? Let's take this and plug it back in. So if I take W and I plug it back in, I'll choose the first one here. It looks a little easier. I have length, so I'm going to use that fancy L, is equal to W plus 5. And of course, if I know the width, I know my width is 14. If I add 5 to that, well, I know my length is going to be 14 plus 5 is 19. So what are the room's dimensions? Well, the length is 19. And again, this was in feet. So 19 feet. And the width is 14 feet. So there is my sentence. I know the dimensions of this rectangle. Length is 19 and my width is 14. So what I'm going to do, guys, nope, I actually solved it on the same one. I didn't have to. All right, so what I'm going to do is I'm going to stop it right here. Make sure that you guys move on to part 2. Okay, because I'm running out of time. It only gives me a certain amount of time. So go to part 2. Go to part 2, and I'll see you guys in a second.